Go. Welcome, Karl and Radu, on stage with the first talk.
Good morning. Good morning. You're way too kind. I mean, wait a bit before you start clapping. So let's start with introduction for the people who don't really know us, or even for those who know us, maybe we have something new to tell you. My name is Radu Cotescu. I'm a computer scientist at Adobe. I work from the Basel office in Switzerland. I'm a member of the Apache Software Foundation. And for a few years now, I think 3 maybe or so, I'm also a PMC member in the Apache Sling project. I'm the maintainer of the HTL modules in Sling, and I'm also one of the engineering leads on Adobe side for maintaining the specification and the actual implementations. And I'm the initiator of the Apache Sling validation framework, which is now maintained by Konrad, I think, actually.
Right. And I'm Karl. I'm also working for Adobe, for the Basel office, but remotely from Berlin. I'm a long-time member of the Apache Software Foundation, mostly coming from Apache Felix side. More recently, I'm active in Sling now as well. I'm a PMC member of both and the current VP of Apache Felix. And I happen to be the co-author of the Manning OSGi in Action book, which is old, but some of you might still know it.
So let's start talking about Apache Sling Scripting Reloaded. For those of you who were here last year, it might sound a bit like a surprise. Isn't this the same talk that these 2 guys had last year, maybe? Are we paying money to hear about new things and we're being ripped off? The thing is that the work we're actually going to present a bit later is heavily based on what we've done last year. So for those of you who are not present, we're going to do a very quick wrap of what we presented so that you can understand where we're going forward with this thing. So last year we presented a new bundle tracker, which enables packing scripts into bundles, which is why the very long name Scripting Bundle Tracker. And when we started with the project, we had 3 ideas and goals in mind. We really wanted to pack scripts into OSGi bundles. We wanted to be able to define the resource types that you're all familiar with as version capabilities. We're basically using the provide and require capabilities mechanism from the OSGi platform. And another goal was to have version requirements. So if you've written components, either for Sling or for AM, you know that sometimes you depend on resource types which are not under your control, and we really wanted a way to control these dependencies even down to the version level, so that you know from the build time rather than at runtime that your project is going to fail on that platform or not. The version capabilities and requirements are very similar to how we consume Java APIs. And we extend this to the resource types that you either delegate to or you extend. So we also have the inheritance mechanism in place, the old Sling resource super type. And again, we wanted to be as lazy as possible, which means allow the platform to do what it does best, wire things for you, so that you don't have to keep track of dependencies and so on and so forth. So after we've set our goals on a board, we really started implementing the stuff. And we ended up with this module, which you can now actually use. I released it yesterday. That's when it hit Maven Central. It's an add-on module to which bundles that provide scripts have to be wired explicitly. So when we designed it, I think we tested it with Sling Launchpad back then 10. And it was working perfectly. Obviously, it works with 11 and so on. We reuse the already established mechanisms for registering servlets in Apache Sling. So there's nothing actually extremely new. We just repacked things and shuffled them a bit around. The module allows you to build lightweight instances, which you can actually throw into production with very little warm-up time. That's only when you're actually using precompiled scripts. So because you're packing the scripts in a compiled form, you don't need the compilers anymore on your platform, technically. Therefore, you don't have to, at the first request, you don't have to start, besides figuring out what's the mapping from your request to your script, you don't have to start compilers. And depending on what scripting engine you use, it might be more than just a Java compiler. On top of that, the module allows you to deploy truly versionable scripts. We have these special files called extends and requires, and extends obviously define the resource types that you inherit from, and requires are resource types to which you delegate. The data slide resource, for example, is one of the example of consuming an explicit dependency, or I think in the JSP tag lib, I think it's called Sling include. And you do this by relying on the OSGi framework. So there's nothing that you have to do, especially to make sure that your scripts are wired correctly. A few years back in Sling, we implemented support for a script cache. And then that script cache is very useful when you're working with script engines that implement compilable. So script engines that implement compilable, in the end, give you a compiled script. And then this compiled script, for every subsequent invocation, you just call an eval method on it with a context. And it saves you a lot of time and a lot of cycles, because you don't have to always compile or interpret the script. Well, it's kind of interpreted, but depending on the implementation, it could be purely interpreted, no other translation before, or compiled. Obviously, because now scripts reside in bundles and not in the content part, so they're not anymore in apps or libs, you reduce the additional pressure that you have on the persistence layer. So if you launch a website and you expect that you're going to have a traffic spike from the beginning, with this module, you kind of reduce a bit the pressure you put on the persistence level. If you use the precompiled scripts, you also are able to start your instance and throw it in production with very little warm-up. In the case where you run your instances where they are Sling or AEM as cattle rather than pets, sorry, the other way around, pets rather than cattle, it simplifies the application upgrades and also the instance upgrades. So when you do the upgrade, you know, again, right after the instance is started with a new version, if the previous application that you had is going to run correctly or not. That's because we, again, have the require and provide capabilities, headers, and then the platform is going to tell you when your bundle is not satisfied because something is missing from the platform. So you don't have to wait until runtime. And because, again, we're lazy and the syntax for the require and provide capability is a bit complicated, even we get it wrong most of the time, actually. We wrote the Maven plugin. And then the Maven plugin, you set it on your project where you provide scripts. Then the Maven plugin is going to look at the file system structure of your project. It's going to figure out where the scripts are. There are some conventions on how you have to organize the project, in the sense that you have to have a certain folder structure. So basically, a top-level folder would be your resource type. Second folder, depth-wise, would be the version of your resource type, and then you have the actual scripts. And then inside this version folder, you have the extends and requires files that we talked about, so that you can extend a resource type or specify that you explicitly need a resource type. And then this Maven plugin reads this structure for you and then generates the provide capability and the require capability headers. They're basically going to be added to some system properties, which are then going to be expanded into your POM file and then sent over to the manifest. I know it's a bit too much to present in 5 minutes, but we just wanted to make a recap of what we've done. So if there's something cool from 2018 that we've done, it would be this. So we basically kept the familiar URL to a script resolution algorithm, but we changed some key components. So right in the center of it right now, instead of having your whole resolution mechanism for scripts. You just have a servlet that's mapped to your resource types. The servlet has access to your bundle context where you pack the scripts. The servlet is actually bound to your bundle context. And then when you're going to render something, the first invocation of this servlet, it's going to look up the class that maps best to your request. It's going to talk to a script engine, either to compile it or to evaluate it depending on the implementation. And then it's going to cache this instance for the class, and then every time you're going to have a subsequent request, it's going to evaluate it with a new context, and then it sends you the response to the user agent. So done with the history lesson in 5 minutes. Right. Let's start talking about new things.
Is that on? Yeah, works. Right. So let's fast forward a little bit because that was last year. So it's a new year. Clearly, there's new topics around. Well, call it the current buzzwords, but in reality, I mean that's just the shift that has happened in the last 5 to 10 years, right? So we basically see that nowadays, the landscape has changed. We talk about Docker and containerization of things. We talk about Kubernetes, which effectively is managing those Docker containers from the outside. A new, reasonable new topic is Karl VM, which is a new Java virtual machine developed from Oracle. We have serverless and AWS lambdas. We have OpenWhisk with all these kind of new things coming out, which for me is very interesting because when I started out with OSGi back in the day, I always liked the modularity aspect. I always liked the service aspect about it, and I'm coming from this modularization and then by extension deployment background, which attracted me to it. So in a sense, the new landscape is a replay of that, just not done inside one process, but as a distributed system, right? So you end up having Docker be the new Java VM kind of thing, right? The runtime that runs your things. It's less of a virtual machine in that sense, but it packages a complete stack. And then you combine those into these kind of microservices, which you can scale out horizontally using Kubernetes as your in a sense, your new Java application enterprise system that you have there, just in the cloud. So it's cloud native, which gave rise to DevOps. So you're much more involved in the actual operating of something, and not only in the development of things. And your software becomes a lot less stateful from a deployment perspective. You're not going against running servers anymore and try to keep them up running. You just basically scrap the whole thing and replace it with something new when you want to change something. That's a completely new world, and you even get again to the whole function as a service, things as a service world where you really just don't want to know about your surroundings at all anymore. It's just basically here's my code, run it. If something happens, if that event happens, run it. Then get out this event and send it to somebody else. I don't care. So
before you switch the slide, I have just one curiosity. Sorry for that. It's totally not scripted. I read an article a few weeks back, and I just want to test if the article was right or not. How many of you are using in your day-to-day job, so not that you've heard about it or tried it once, but in your day-to-day job, any of the technologies from here or principles? Okay. The article said that people who are fortunate enough or unfortunate enough, depending on how you see it, to use Docker, Kubernetes, Graal, and serverless are kind of the 10%. That 90% are doing the grunt work without having access to this technology. They're maybe even stuck with Java 6 or OSGi for the matter.
Yeah.
And we are apparently the 10%.
Well, it's that. I mean, it's clear that these topics are not just starting to come up this year, but they're reasonable new, but they're not ignorable anymore, right? And I think the lineup for this conference here also shows a big shift towards these kind of topics from all sorts of speakers and directions. So really, What we did last year already was kind of inspired by that new world. So looking into how can we actually make scripting be a first-class citizens of the deployment, so that they have real dependencies, and how can we make it so that we precompile them in a good way and take advantage of the OSGi wiring, which had in mind the idea that you would end up using it in the Docker container, right? Where the difference is mostly you don't want to deploy them at runtime and see if they work. You want to know that ahead of time and then get them all together as dependencies and put them into a Docker image, which then is immutable, right? So that was one prerequisite for doing that. And we try to continue that work this year by looking into what would Sling look like, or an optimal Sling Docker image look like right now? Where can we, how good can we get? And then at the end I have some thoughts about where we can go from here. But what we have right now is a minimal Docker setup for Sling. I mean, there's going to be other talks. I think Tomek is here. He's going to talk about a bigger approach done by AEM later in the conference. We have Robert talking about some of the surroundings and how you can get your bigger systems modularized in this new world, I believe, today. So there's other talks about that, but this one is really focusing on, okay, if we want to package Sling, how can we make it a reasonable lightweight Docker image, which has a small disk footprint, has a small memory footprint, has fast startup time, and is reasonable stateless so that we can scale it out horizontally, for example, with Kubernetes. And so in other words, the goal was, can we get something that's below 100 megabyte disk footprint, And so we set out with that, and we have a demo later on, but also all that what we used for it is in a GitHub repository or in the whiteboard, I believe.
It's going to be after we finish.
So you can easily look at that then to try to pick it up, should you be using plain Sling someplace. But we're using the feature model to do all of this. I have another talk with David Boschert on Wednesday talking about it again. We presented it last year already. But it has some nice features for that, because it has a launcher that not only allows the feature model to be all in the Docker image, but it does minimal copying of things inside the image, so it all starts from whatever is there already, so that is optimized for it. We have Carsten, who added a new feature to the Felix configuration admin, and we use that in the feature model, so that nowadays you can pull it into a mode where the configurations are not even stored on the Docker disk or someplace, they're just kept in memory, because we assume, well, yeah, if you start your instance, but when you kill it, it's gone, right? So it needs to be all in the feature model, and we use JLink to create a custom JRE with only the dependencies we need for minimal Sling. I talked about last year with Carsten together about the modifications we did to Apache Felix to make that possible, but you can basically really JLink a platform together which has a minimal set of required Java modules, and only those get picked up by Felix then. And I did some work during this year to get Sling, or at least the core Sling, to work without the Java desktop module, which I like because it's big and has all the AWT stuff in it. Unfortunately, it's this kind of kitchen sink module, which is 30 megabytes big, and it's very hard to avoid it. So I had to do some trickery with Sling, but it's all in there, so the core of Sling doesn't require Java desktop anymore. And yeah, you can base it on Alpine, which is a minimal Linux flavor, which doesn't have a full glibc. It uses Musel, so it's a little bit more lightweight. We have an example of that too. But if you do that, then you can basically get a working minimal Sling system in under 100 megabyte of disk footprint Docker image, which is stateless in the sense that the setup itself doesn't maintain any state in the container once it's running, but also we try to get rid of as much as possible from the stateful content and just assume it's a remote setup. So Carsten made it so, helped a little bit, but I think Carsten, for the most part, worked on making it possible to start Sling even without having JCR API around at all. So we not only can remove Oak as an implementation, we can also remove all the API bundles from it, and it still starts up, which is nice. And then in our demo, we only use the resource provider to expose remote resources then. I have a talk again with Carsten tomorrow about resource providers to refresh some people's memory about how they work. But the idea is you can just have a custom implementation mounted under content, for example, and expose resources via it. And well, that's what we do. We use precompiled scripts to render those, which is nice because so there doesn't need to be apps or libs, so no content representation of scripts, no runtime compilation of them. So we end up with a very minimal thing using a new, is that new? Well,
No, that's okay.
Right. Abstraction that Radu introduced as well.
Right, so because the restriction of our system is that everything has to be remote, so no content whatsoever is going to be embedded except for maybe configurations, we were thinking to delegate everything to a cloud storage service of your choice. You're going to see in the demo what we picked. It's kind of hilarious, but it does the job for a demo. And because of that, we said, okay, if we're only going to work with remote resources, we kind of have to find a unified way to expose them so that implementers of this new way of consuming content in Sling don't have to work that much. That's a very reduced footprint of this interface. It's only supporting for now the read use case. So basically, from a remote storage provider, you get a remote resource reference that identifies a resource that you're going to render in Sling. And based on this reference, then later if you need a file from it or actually a directory, you pass it on and then along with the authentication info, and you get your file and directory. File and directory are interfaces specific to this package. File extends remote, actually both of them extend remote resource reference. Difference is that file gives you an input stream in case you need to read stuff, and optionally a MIME type. And then directory, guess what? Children. We still need to render children resources. The API is experimental, no the exclamation mark. It's something that I think I wrote in around a week, give or take, with some multiple implementations. We're going to have one pushed to the whiteboard after this talk. The idea was that we wanted to have different remote resources hooked into Sling via resource providers. And the implementation that's in the bundle does a one-to-one mapping between a resource provider, the familiar object that we use to get resources in Sling, and a remote storage provider. And this is done based on some OSGi registration properties of the remote storage provider. The resource tree is then based on files and folders. It's very familiar to JCR, more or less. But we do have a special .sling.json file for now for defining properties. Because most cloud storage providers don't necessarily offer you a metadata service. This .sling.json file is again very familiar. It uses the same format that a Sling content loader uses, and then we read it and generate additional properties either for a folder, for example, or for a tree of resources. By default, the implementation includes an in-memory caching layer. And in this caching layer, we only store the resource tree, nothing more. When you need something more than that, so a file, or you need to go and get the children, depending on the type of remote storage provider, and by this I mean authenticated or unauthenticated, some things might be cached or not. We needed this caching layer because otherwise things would be terribly slow. So if it always go remote to access a resource, it would be terribly, terribly slow. And again, it's a POC. A more serious implementation would probably use Redis or some other dedicated caching solution, which we wouldn't have to maintain. So how does it look like? We have the usual flow of a request into Sling. Basically, that dotted rectangle or dashed rectangle is the Sling application. So you have your usual HTTP request, which hits the HTTP API. It's mostly the Sling engine part. Then from there, depending on what your application does, you either access a domain-specific API or an implementation, for example, Sling models. You anyways end up at the resource API, and there at the resource API is what Sling does. It looks for the best resource provider matching your path, and it's going to try to serve a resource. With our in-memory resource cache, and because we have a one-to-one mapping between the resource provider and the remote storage provider, we always query the cache for a certain resource. If the resource is there, we serve it obviously from the cache. If not, then the request or the processing flow actually goes to the remote storage provider, which in turn accesses this remote storage service that you'd like to use. And you can see in the diagram the difference between network calls and in-process calls. So Karl, you're good at summarizing things that I've done. Go ahead.
Well, I mean, that's basically just saying what we're going to show in the demo in a moment here. So we're going to package the whole thing up as a Docker image. Basically the setup is we have a minimal Sling feature set, which we can aggregate together with the application bundles that we created for the scripting. They contain all the scripts precompiled, and we put in an implementation for the remote storage API that Radu just introduced for Dropbox. We aggregate all of that with the Maven command. We can then have another Maven plugin that generates a Docker file out of it, and you end up with a really nice small Docker image. And we're going to demo that now.
Now, if you'd be in the role of the web developer having to write a web application on top of Sling, you'd basically be developing only the box that's on the top left part of the image, and then everything else would be aggregated for you, including the generation of the image. So let's switch to the quick and dirty demo. Hopefully the network is going to work. Our demo has exactly the modules that you've seen here. So we do have a base Sling setup with 65 core bundles. We do have the remote storage API that we talked earlier. We do have an implementation for Dropbox, because they're quite nice in the sense that you can start an application in around 2 minutes. And then we have some scripts which are going to render a page, and everything is done in a Docker image. I wish I could move. Yeah, I can. So I'm going to skip running the build. Sorry. Wait, I can do this actually. Live typing on stage. Better now? Okay, great. So I'm already in the demo folder. In the demo folder, I have basically the whole application packed. It's referencing some Sling feature files, and it brings my scripts. And then here we do have a Docker compose file that shows you how the application is going to be packed. So what we have is our own Docker image built in this project. And then we do have some secrets that we expose, namely the Dropbox access token. We have an Nginx configuration. And in this case, the web server is going to serve as a load balancer. And that's about it. And then when we start the application, because it's quite tiny, you can scale it up to how much RAM you have on your machine. Karl actually tried it with 200 megabytes for a Sling instance, and it was perfectly OK. You launched how many?
I get about 25 on my older Mac.
Exactly.
Side by side within a minute, so that's kind of
right.
nice.
So let's start it. When we did say those 10 seconds, it's not actually with Docker Compose. It's just with a Docker container that starts, and it's already able to handle requests. If you start up with Compose, it has to create your networks and hook up your load balancing. But the application is already running, I guess. We're going to see. And now the first request is going to retrieve stuff from Dropbox. So it's obviously going to be a bit slow. But then after that, all subsequent requests, because the resource tree is cached in memory, are going to be relatively fast. I'm going to refresh again now that it has created the resource tree in memory. So everything is, sorry, I pressed on T. Everything is super fast. Obviously, you can go onto the other individual pages. They're going to be fetched and brought into the cache. Then another refresh, page is there already. Now, assuming we would change content, I'm just going to use the versioning feature from Dropbox and change the JSON file that provides you with the text here, which is just a resource property. So you're going to see a change in the text of the latte description that we had before. And we told you that we have a caching layer. There's also an event mechanism, so we kind of know when something changes on the Dropbox side. We refresh. We see again that the page is slow because it had to fetch content remotely, but then again is going to be cached. And then because the content is completely separated from the application, you can start scaling horizontally and throw in as many servers as you'd like. Obviously, it's a proof of concept, but it's trying to open the idea of trying to use a distributed content storage mechanism.
Right. No. Oh, okay. Right. So we're a little over time here, so don't have that much more to say, though, luckily. So what was the demo about? Well, the nice thing is we have a really small Docker image. It's 75 megabytes if you include the demo scripts. It has, as Radu mentioned, it can run in 200 megabytes of memory footprint, and it starts up reasonably fast until it actually renders the first scripts because it doesn't have to compile anything. And that's even more important for me because, as I said, the outlook I wanted to give is that I'm personally motivated and want to work on the future here a little bit, and that is going to be that there's a new OSGi RFP out there, 196, together with David Boschert and Carsten Ziegler. I'm working on that one, which is the idea, and I think they mentioned it in their talk a little bit in more detail. But the idea is that we can get all of this running inside OSGi, but within one class loader if we want to. And then if we have that setup that we have here, where scripts are precompiled and can be and all baked into the image, and all the bundles and the Java modules are baked into it, if we get this mode, which is tentatively called OSGi Connect mode, then it should be possible without hopefully too much difficulties to take advantage of the new Graal ahead of time compilation things that are going on, and potentially then take something like we have right now and compile it to native code, which would hopefully then give us even more benefits in terms of size and memory footprint and startup speed. If we could get this done, it's not something that I could explore for this year's adaptTo, but maybe, hopefully, next year I could come back and show something in that direction. That's it.
We still have, because we started a bit early, we would have 3 minutes until the talk would end. So if you, well, scheduled. So if you have any questions, Robert.
Microphones already.
You can ask and I can repeat a question.
Okay.
I can hear you.
Thank you. So my question was, you mentioned building a custom JVM using JLink.
Yeah.
Did you select the modules manually, or is there some tooling current or planned to say, I need these modules for this provisioning model, feature model?
There is a tool which comes with the JVM, which is called JDeps. So you can run JDeps against a class path or a setup of Java files, and it's going to look at what's required, and it spits out a list of Java modules that you need for it. In our case, it can serve as a basis, but you cannot use that. It's in the slide. I said JDeps, but you cannot use it the output directly, unfortunately, just because. I mean, I'm known for coining the phrase that, OSGi people, they just cannot program more than 3 lines of code without doing something funky with a class loader. So, I mean, the problem is all our Sling core modules are optimized for optional things, right? For example, the JCR-less, so that you don't need the JCR API. Well, that relies on OSGi allowing you to start up and then not finding the class, and you catch the exception, and then continue without the features that you wanted to, for example. But for JDEPs, it's going to look at your bytecode and see, well, they're referencing something from JCR, right? So they better need somebody providing it. Right, so the same happens for the core thing. So, for example, Java Desktop would end up being in the list of what JDEPs computes for you. If you look at our core sets of bundles, it just isn't in possession of all the knowledge that would tell them that, yeah, you can. It's optional, right? So, but yes, for the normal use case minus the optional constructions, JDEPs is not too bad. So basically, you just point JDEPs at your class path and say, well, what do I need? And it's going to spit out a bunch of Java modules you need.
It gives you a base, I guess, and then with trial and error, you can figure out if you can remove more from that base. And the problem is with the optional mechanism, that you cannot really detect it. And also, if you have, for example, that was the funniest part, if you have dependencies which are actually in the class path, JDEPs is not going to be able to figure out that module A depends on module B, so you're going to see some modules with unresolved dependencies, but that means that they should actually be there. So that's the OSGi stuff. But it's possible to get at least a base and do a trial and error.
But for the core JDK modules, if you were talking about additional bundles that you want to deploy, it should be enough to run JDEPs against them and could tell you what Java modules you need, at least from the core set to add. So that's possible.
Okay. So thank you, Karl and Radu.
Thank you.